Plastics are super useful, but depending on how we make, use and dispose of them, they can be really damaging for our environment. Now we can make plastics which are renewable or biodegradable, but in order to do this efficiently, we need to know as much as possible about the molecules that they're made of. Molecules are really tiny, but knowing what molecules are doing on their tiny scale can help us solve big problems, like designing sustainable processes to make sustainable plastics. Molecules are constantly zooming and jiggling around in mixtures, just like fish swimming around a fish tank. But how can we measure how fast the molecules are scooting around? I use a technique called DOSY. Don't ask why it's called that, but it uses huge magnets and radio waves to measure how fast molecules are diffusing through a mixture. So we use DOSY to spy on the fish in the fish tank and measure how fast they're swimming. When we're watching chemical reactions, we can do it the simple way, offline sampling, where we take little fish tanks out of our big reacting lake and put them separately into a machine to analyse them. But this takes time, and there's a delay between taking the sample and getting the information back. Now there's another way, which is a bit trickier to set up, but which allows us to analyse our reactions in real time. Now this is pretty exciting because it gives us a more realistic picture of what's happening and can even let us in on secrets that we couldn't find out by other means. We do this real-time monitoring by turning our reacting lake into a river and flowing it through a tube inside our probe and collecting lots of data on it as it flows past. But this complicates things because now the fish, our molecules, are swimming in a river that is flowing much faster than they're swimming. So how can we measure the movement of just the fish and ignore the movement of the water? In my PhD, I found a way to do exactly this. The trick is to use a modified DOSY experiment which cancels out constant motion like the flow of the mixture and allows us to focus in on the movement of the molecules themselves. So in effect, I've jumped into my flow DOSY canoe and I'm floating along with the fish. From this vantage point, it's easy to see how fast the fish are swimming rather than just seeing them rushing by in the river current. I'm using this technique to study the formation of a renewable polymer or plastic. Flow DOSY allows me to watch polymer molecules growing in real time. As we learn more about how these molecules behave, we can design better sustainable plastics. So studying these molecular fish swimming in our river can help make real rivers and oceans a safer place for real fish to live.